Hello. Today I want to talk about doubles. A double, I'm going to read this to you, is an object that stands in for another object to speed our testing or make our tests more independent. The way that we're going to, the way where the name double comes from is it's like a stunt double in a movie, for an actor. And so you have this actor, and we don't want the actor to get hurt in this action scene. And so the stunt double comes in, takes all the blows, takes whatever happens. No one knows the difference when they watch the movie. The double has basically allowed us to, film this without hurting the actual fine, actor who's paid millions of dollars. So we want to be able to have doubles for our testing because there's going to be times when, we don't really want to engage with the other objects. We want to focus our unit testing or our testing on a narrow set of code, and we don't really want to deal with the other objects because we want our test to be independent, and we also want it to be fast. I do want to mention here, we keep talking about testing having to be fast. In MSci 342, testing being fast isn't going to be a problem because I really doubt anyone is going to write so many tests that they're just like, oh, I can't believe these tests aren't finishing. If you get to that stage, you have done a wonderful job. You've written way more tests than I could ever envision for the size of the system you have. This whole speed of testing starts to become a really big issue when we're dealing with a large development project. And again, the amount of test code is gigantic. We really want the tests to run really fast. Otherwise, we wait too long to find out the results. And then we find ourselves not wanting to do as much testing usually because we're waiting. So that's not, don't worry so much about fast. And so I say that I don't want people to, I'm going to talk about something today, these doubles. Don't go necessarily out there striving to use tons of doubles in your testing with the idea that it has to be done to speed things up. If you're having difficulty testing something, and having a double will make testing easier, again, by making things more independent, that's a more fundamental thing. And absolutely, well, if it's going to make it easier for you to test something, that's absolutely a great use case. I would not be focused on optimization and speeding up your testing. There's a famous saying, optimization is the root of all evil. Basically, we're not talking about operations research and optimizing things. We're talking about, and it's premature optimization anyway is the root of all evil, which is trying to speed things up before you really need to speed things up. Often wastes a lot of time. Coding results in bad code. It's better to code to make things correct and then go back and realize, that's where the time is being spent, and let's speed that up. Anyway, so let's talk about doubles to have a stand-in. All right. I have here written up here the example that we used with dependency injection. So again, we've got some user profile class, and I've left out all the other details, okay? But then we had this method where we've got a birthday, and we pass in what today is. And then so if today's day is the same as the birth date's date, and the today's month is the same as birthday's month, it is true that today is the birthday for this user. Now, again, we had this special case where a user might have been born on February 29th, so their day's 29 and their month's 2. Now, in a situation where it's not a leap year, we still want to be able to wish them a happy birthday. So if it's not a leap year, so not today leap, and it's their birthday, so if they have a birthday that falls on February 29th and today is March 1st, we're going to celebrate their birthday on March 1st, which is in a non-leap year is the day that follows February 28th. Makes sense, right? So we return true. Otherwise, in those cases, we return false. Now, this was nice. We were able to get rid of the dependency on the date class here. And so this code is written, and all it needs is something passed into it that uses day, month, and leap. All right, so with that in hand, that's what we're going to do. There is a small issue here. And we gave this example actually the last time. I said, oh, well, to test it, it's not going to be that hard now. We'll just have to use the date class, and we'll set the date class to whatever day we want, and then we'll pass it in here, and we will have set up a user profile, and we'll be able to test it. I said, that it's going to be great. It's going to be easy. Now, this is a sort of a forced example. Again, we try to use examples that are simple. It might not be the best use case, but let's envision I don't know what years are leap years and which years are not leap years. And I don't really want to go look it up. It's not that hard to do, but I just don't want to do it. And I don't want to have to rely upon the date class to return to me whether it's a leap year or not. I want to make my life easy. I want something to stand in for the date class that's really simple for me to determine and set and fix what the day, the month, and whether it's a leap year or not. I just want to be in control of it. In other words, I don't even need to know what the year is. I just need day, month, and is it a leap year? And so what I go, wow, if that's what I want, and I don't want to be bothered to look up when the last leap year was, why don't I make a double? Now, this is not the best reason for making a double, but this is an illustrative example of making a double. All right, so what I can do is in my file where I'm putting my tests, I can just go ahead and have an additional class in there, and this is going to be a double for the date class for my use for testing. All right, so I'll just go ahead and do a class. I'm going to call it date double. Now there are special tools to help you build doubles on the fly. And when it's really simple or you want to do that, great. Go ahead and use them. We're going to look at one later when we want more functionality out of a double. But I agree with Sandy Metz. It's just like, often the easiest thing to do is just make your own double. You'll be able to see it. It's really clear what you've done. It doesn't take that long. All right. And so just feel free to write them, and you stick them in the same file that the other test code happens to be. So I'm going to go ahead. I'm going to use this attribute reader functionality to expose the attributes that I'm going to make, the month and the day. Okay. And then I'm going to create the constructor, the initialize method. So def initialize. Now, one of the things I actually don't like about the date class is it uses positional arguments for the month, day, and the year. And I have to go to the documentation for the doggone date class and look up very carefully, do I do year, month, day? What's the order that I put them in? I don't like having to read manuals. And in fact, so making a date double, I can actually fix that. Besides the code being really close in my testing file, so I could even just go look, it's just there. The other thing that's really nice about it is I can actually say, I want to make this with named arguments. Okay, so I'm going to do that. So I'm going to make a named argument month. And so we make a named argument by using the I don't know, I guess the string, the name here, and then we put a colon after it. And also I'm like, I like defaults. Why not? Let's have some defaults for this. So month, and let's say the default is January, so 1. And my day, I'm going to say it's January 1st by default. And I'm going to pass in whether it's a leap year or not. And I'm going to say by default, it's not a leap year. All right, so we go ahead in here. And now I'm going to have my member variable month. And I'm just going to set it to month. My member variable day. And I'll set it equal to the passed in day. And I'm going to have a member variable leap. And I'm going to set it to the passed in leap. So a very simple constructor here for this class. So the attribute reader will give me back month and day, but because I've got this fancy leap question mark method, I actually need to create it. So def leap. There might be some way to use attribute reader and stuff with the question mark, but I actually couldn't find a way to do it. So this does work. So def leap question mark, and all I do in here is I return my member variable leap. So it's just a simple getter method for this class. And then I'm going to end my double. Okay, this is all it takes to go ahead and define my double for the date class. Again, I just need a class that does month, day, and leap. And with this thing, I'll be able to create a new date double object. And very simply, I will be able to set it to whichever month, day, and is it a leap year or not that I want. And I can use that in testing. And really, I mean, you should really notice here that, this here, look, there is no, just to be really clear about, no logic about computing the leap year, okay? The real date class absolutely does that. It goes and it takes your month, your day, and your year, and does some if statements and whatever special rules it has to determine is it a leap year or not, and then returns true or false. All I'm doing here is spitting back out the value of leap. This is what doubles often do. They are practically brain dead. They are trivially simple. I mean, there's no code that runs faster than just returning a value. Okay, so not that we're really worried about the speed that it takes the time to compute, is it a leap year or not? That's not much code, but this does run faster. And as well, by using this, I actually won't be dependent upon the date class. And so my tests can actually have a sense that they're a little bit more independent. So let's actually show you what this looks like to use this in a test. So I've got a file, and in it I've got require, the mini test stuff at the top, anything else that I want. And I need a better pen. I have to order new pens. All right. Class, I'm going to call this test user profile. And again, this is an example where I am testing actually outside of Rails. So all I'm doing is inheriting from mini test, test. In Rails, again, we would always inherit from the appropriate derived class, whether we're doing our model tests, controller tests, or our system tests. Now, I want to be able to easily make one of these user profiles. And rather than call and show and waste our time right now with the create methods and stuff for a class I haven't even fully defined for you. What I want to do is I'm just going to show you that what I would do is I would go ahead and I would create a method inside of the here. And again, mini test is just Ruby. So all you need to do, if you want a method to help you with your testing, make a method to help you with your testing. It's only the methods that start with test underscore that are going to be run as a new test, but those methods can call any other method that they want. Okay, so I'm going to go create a profile. The idea is I'm going to write this method such that I can create a profile with a specific birth date that I want. This is I'm making myself a helper method that'll make it easier to create one of these user profiles. And so I'm going to go ahead, I'm going to say it's got a month, and it's got a day, and I'm going to use named arguments again so that when I call it, I do have to specify that I have a specific month and a specific day, and I could call those in any order, so I could go day and month, but I always have to use the named arguments in my call. And so in here, I would write some code where I call user profile new or user profile create, and it would create the user profile for me. Great with this, and I would specify, and I'd get it to be sure that it's got the right birth date. Wonderful. And then I'm going to go ahead and return. Let's say I've set it up, and so I have some variable user profile here. So I return the user profile that I've created. I'm just leaving out that code because we don't need to see me make a bunch of calls to a class to set up its birth date. You might say, well, what about, well, do you need to have a year? I'm sure there needs to be a year. But again, someone's year of their birth date is not necessary for me when I'm testing it. So this code in here will use a default year and a whole bunch of other default data to make a profile, because a profile probably also has things like a name, it might have a location, there's all sorts of stuff, and I don't care about it. The only part that I care about when creating my user profile is that I be sure that it has a specific month and day, and then I'm going to write code to set it up there. I plan to get to talking about factories, and so this is basically like a factory. Give me a user profile that's valid, but make sure that it has a specific, I'm going to set it up to have a specific month and day, and this is what we use factories for. You can basically write your own factory method, and that's what I've done here. All right, so let's actually set up a test to demonstrate the use of the double. And so I'm going to write a test. So test underscore birthday, and it's a leap day, so it's going to be a February 29th. And I'm testing that it's a non-leap year scenario. Okay, and I would have other tests that I'm going to create for, oh yeah, it's a leap day and it is a leap year. Oh, and then I would have a test where it's a regular day and it's not the person's birthday, and it's a regular day and it is their birthday. So I would be testing all the possibilities of the birthday method. So there's probably 4 tests or something like that to write. This is just one. And so I come into here and I go ahead and, yeah, I want my user profile. Hey, it's really handy. I created a helper method. So I'm just going to go ahead and call my helper method the create profile with birth date. And as I write this, I wonder, why did I make it such a long name? But we like long names. They're nice. They can read nicely. And so I'm going to pass into the here. Again, I've reminded myself it's the leap day. So I pass in month : 2. day colon 29. All right. Sorry for running out of space there. All right, great. So that goes and runs, makes me a user profile, object, sets its month and date for its birth date to 2 and 29. All those other things are set to who knows what, but I don't care. And I get back my user profile. That's great. Now I'm going to go and I want to say what today is. So I'm going to use my date double class to make a new date double object. And I'm going to specify that today is March 1st and it's not a leap year. So leap false. So I pass those in. And again, because these are named arguments, I could have done day 1, month 3. I could have started with leap first. I can put them in any order with the named arguments, and that's really handy. And also, by the way, these named arguments are really nice. If you see the way this code gets written, you don't have any doubt about why I'm passing in 2 and 29 here. You don't have any doubt about the month, day, and the leap settings either. By using named arguments, a lot of the code becomes a lot more readable. I certainly encourage you to use them. You don't see them in Java, and so you've gotten used to sort of positional arguments. But named arguments, as you can see, can make your code a lot more readable, and which aids for maintenance. And it means it's less likely that other developers, when they come into your code, are going to make mistakes using it. Okay, so I've done that. So all I really need to do here is to actually assert that the birthday is true. So I'm going to do assert, which means I'm asserting that the following thing is true. So I'm going to take my user profile. I'm going to call the birthday method on it. And I'm going to pass in today. All right. And then I'm going to end this method, and I'll go ahead and just say that we're ending our testing class here. So I run the Ruby code that this file is in. It knows because of the require Minitest auto run, or if this was in Rails, it would know how to run the tests for you. And it's going to come into here and it's going to, oh, I found a method that starts with test underscore. It's going to run this. We're going to make the user profile. I'm going to make my date double object. And I'm going to go ahead and call this and assert that it actually is true that when you have a birthday on February 29th and it's a non-leap year and it's March 1st, that this method should be returning true. And see the way that I was able to do this with not relying upon setting up the today, what today was, with actually using a date object. I'm able to just make a double to stand in for it to do what I need it to do, which is to respond to calls on month, day, and, well, and you don't see it here, but leap question mark, okay? This is really, it's sort of cleaned things up for me. Is it really necessary for this example? No, it's not really necessary. It's not hard to go look up what a recent leap year was and trust that the date class will do things correctly, and I set it up. I would need to definitely put in a comment into my code that says, look, in this year, this was a leap year, or this was not a leap year, and you could verify this by going and looking at the following calendar page or whatever. It's going to take some more documentation. This, by the way, doesn't require any documentation. This is self-documenting. It's very clear what's done. You'll have in the same file the date double. So that's what doubles are. Now, what we know. So what happens though is you go and you start reading about doubles on the web, and you're going to see that there is lots of terminology and lots of different ways that people call things. It seems as though a huge number of people apparently, so I don't know, I haven't dealt with this, but a lot of authors warn that people go around talking about mocks. Oh, we got to mock it, mock it, mock it. And they're using this terminology mock indiscriminately. Double is really the generic term, and then there are specific types of doubles. So there's a whole bunch of them that people have come up with names for. So this naming comes from Martin Fowler's webpage where he lists these. So one type of double is called a dummy. And on a dummy, I mean, in often cases, apparently the easiest and simplest dummy is just the value nil. So, oh, this method requires me to pass it something. And I don't care what it just needs it. It needs it like to hold on to it and do, so you could pass nil or something, if that works. But, dummies, the idea is it's some object that gets passed around, but otherwise is ignored by the code, You just need something to fill in so that the doggone code runs, but you don't care what happens to that object or what values it's just a placeholder. So you might stick in a dummy, and that, again, it stands in for some object that you needed. It breaks a dependency usually. It speeds things up, whatever. So dummy's the simplest one. Then there's the idea of a fake. Now a fake, it works the same as the other object that you are doubling for, but is often simpler and faster. And the example given is in-memory database. Okay, so when you're using PostgreSQL or whatever, this database, and we have it set up actually, you're using it in dev, you're using it in test, and you're using it in production. There's a lot of people who don't use it in dev and test, and they use instead SQLite. And then in production, we use Postgres. And so there's another step that you could take in dev and test, is you could use SQLite, but use it and say it has to be an in-memory database. And in this case, the in-memory database doesn't save its values to disk. It's just always running in the RAM of the computer. Anytime that you have code that has to write to disk or read from disk, even if we're talking solid state drives like we often do nowadays, it's still 10, 100, million times, it's gigantically slower than going to the RAM and getting the values. And so a fake, you could have as a double something that actually is a completely programmed, truly functional relational database, but it keeps everything in RAM so that your tests run faster. That's a fake. You wouldn't want to use that in the actual production environment because we want the robustness of things being saved to the hard drive in case we have failures of the computer. All right, next up is the idea of a stub. Now a stub is an object that when you call methods of it, the methods return, canned answers. So these are, let's say we had some object that's supposed to return, the current temperature. Well, again, we could have it always return that it's 20 Celsius, whatever we want. And we call temperature and it always just returns 20 Celsius. It doesn't actually have to go out to the temperature probe or go out to the weather service and make a request and find out what the current temperature is. And especially, imagine that if you had a test that depended upon what the temperature was. Maybe you needed to display different colors for different temperatures. You would want to be able to control that. And you'd want some sort of double that, is set up that way. So you might stub one out so that it returns, 20 or 30 or whatever for the temperature. It's similar to the example I just gave, except those weren't, that's sort of, those are canned answers that I'm able to give the object at the time of its creation. Often when we stub things, it'll actually be literally hard coded into the method that it should return. So a stubbed date double would probably always return the same day, month, and leap values, no matter what. We sort of made a programmable stubbed double for the date double, which is it gives us a little bit more utility, but when we use it, we always have to set those values. A very simple stubbed version, you wouldn't have to give it those values for it to return to you. It would just always just spit back out those values. But certainly in our case, ours always returns these. So I'd kind of say it's kind of like a programmable stub that we made. All right, then there are these doubles, which are called spies. Now spies are like stubs, like a stub, but they also record various info about how they are used. So you could kind of think of them, they might very well keep sort of a log. Oh yeah, we called temperature 10 times and it'll return that. Or, oh yeah, I know that you sent you called my send email functionality 30 times, whatever it was, So the spies can keep track of things in how the double is being used. So it's sort of a more advanced version. The most, the next, probably what's considered the most advanced is the mock. A mock is set up to be able to respond to a specific call or a whole bunch of calls. You could actually do that, but you're basically saying this object I expect it to receive a call on this following method. All right. So it's set up to be able to respond to a call and can verify if so called. So basically, it's kind of like a spy, but its functionality is oh, you're telling me that let's go back to that temperature method. Oh, you're telling me that this temperature thing should have been called? All right. Well, I'll sit around and wait. Oh, yep, someone did call my temperature method. So if you ask me to verify was temperature called, I'll return true then. If no one ever called my temperature method, if you ask me to verify that, I'll return false. Now, let's actually give you an example of a mock so that you can see it in use. All right. Here we go. So the temperature one, I guess, is not a great example. So let's talk about instead, let's envision that you are, that you have, so our example that we're going to create is a security system. So you have code that for the security system, that when certain conditions occur, an alarm is raised. So when certain conditions occur, an alarm is to be raised. And in a real system, we could think about like a deployed security system. System raising the alarm, fires or, what wording did I, let's say plays allowed siren, whatever, we don't want, when we're testing, we're not actually going to want to be having this thing set up with an actual siren and hearing it wail. We want this to run in a test environment, and all we want to know is that we want to test some code, and we want to be sure that it raises the alarm when these conditions occur. If it doesn't raise that alarm for us, our code is broken and we have a terrible failure. And so all we're trying to do is set up something to be like, let's make sure that the alarm was raised, but let's not actually raise the alarm. So let's not actually trigger the siren to go off. And so what we can do very nicely is we can set up a mock. Minitest has some functionality to allow us to do that. So let's go ahead and let's say we're working and we've got some member variable here. We don't even need to be member variable. Let's just have it be simpler. Let's just say we have a variable alarm, and we're going to go ahead and ask Minitest to create us a new mock. That's all it takes. So Minitest : mock period new. So create a new mock for us and store it here in alarm. Right now, this mock doesn't know about anything. All it knows is I'm a mock. All right. Now we can take the mock and we can tell it what it should expect to be called. Okay, so which methods does it have that it should be expecting and keeping track of, was this method called? So let's say the normal alarm has a method on it called raise alarm. Okay, so we are going to this mock is going to be designed to pretend to be the real alarm. So it's a double. So just like the date double, this guy's an alarm double. And we're just creating it really quick here. And so we say it should expect a raise alarm method call, and all the methods return something. Now this is just simply a method to raise the alarm. It doesn't return a value. So what we'll do is we'll just simply say it's value that when raise alarm is called on this alarm, it will return nil. Okay, so what we do then is we go ahead and now we're ready to arrange and set up our security system. So let's say we've got some class called security system. And we go ahead and we create a new security system. And because the security system was created and has used dependency injection to allow us to give it the alarm class rather than it being hardwired to a certain alarm class, because maybe there's all sorts of different alarm classes that we would want to be able to enable it to, and we'd want to break the dependencies. So it's set up in its constructor to allow us to pass in whatever that alarm class is. Now again, our mock here is designed only to pay attention to the notion of raising the alarm. But here, that's all we need when we're going to be testing our security system in the following code. So we create this, and we've sent in the mock, which is just a double. It's playing the role of whatever the actual alarm class is. And then we would write code in here where we act on the system. We'd send it some inputs or whatever that should raise an alarm. Because again, we want to be sure that when we send those proper conditions in to the security system that the alarm is raised. So in here, I'm not going to write the code, but imagine you've got that code. I've done something that the security system should have resulted in it raising the alarm. So calling raise alarm on the alarm object. Well, now to make sure that security system did its job, all I have to do is I can say assert alarm.verify. All right, and so the mock object here, what it does is, again, we've told it to expect this, and so it's sitting around and waiting. Did someone ever call raise alarm on me? And so if someone did call raise alarm on that object, verify will return true. Okay, if this code that we had run in here didn't actually raise the alarm, the verify would return false. By the way, there is another way that we could have written this. There's a shorthand. It's not much of a shorthand, but there's an assert mock, and then you just say the thing that mocks. If you go look at the code for assert mock, all it does is it returns whatever the object is that you've passed into assert mock.verify. So basically, you could just assert whatever this object is, verify, or call assert mock on the object. Whatever works best for you. That's what mocks are. Again, they're just a special type of double. They stand in for an actual object with the notion that they'll keep track of whether or not a method has been called on them or not, and then let you verify whether that method was called. Yeah, and it's for a single method. If you needed something more complex, you've just already seen it's not hard to go ahead and write your own double. You could easily write your own fancy, spy that keeps track of different things being called on it, and then you could, after it's been used, you could inquire to it, hey, did these things happen? You could assert that they should have happened or should not have happened. This is just flexibility. Now, a word of warning that there's a lot of people out there who are like, oh my goodness gracious. Developers get so excited by this cool word mock and these cool things doubles, and before we know it, they start putting mocks and doubles everywhere in their code, just tons and tons of them, and now their test code is a mess, and there's more mocking than you could ever believe or there should ever really be. So again, use doubles and use mocks when you're like, oh, I can't figure out how to test this without using one. Or, oh, if I don't do one, the testing's going to be really slow. Where are things going to be really slow? I think a place where things are going to be really slow for you, not in the project you're working on right now, but in your life, is you're going to be dealing with solvers for optimization problems, for example. And so these solvers have to get the problem all set up, and then they have to run. And solvers, they're designed to be fast, but relative to other code, they're not fast at all, especially if you were to have an actual complex problem to be optimized. And so you could envision using some sort of fake, or you could use some other sort of double or a stubbed one to basically be like, oh yeah, solve the model for me. But then the truth, it doesn't actually go and solve the model. It just returns, it's already got a pre-canned solution for a problem that the double has been set up with. And so you need, you're testing code that needs to use a solution from a solver. You're going to see yourself stub that out. So it just returns the solution immediately for you rather than actually running the big optimization problem on it. And that's the type of place where you're going to see yourself probably wanting to use a double to speed things up and to break a dependency. Other places where they come into use is when you're needing to test failure conditions. And the failure conditions, you need to be able to force them to happen, but there's no way to force them to happen programmatically. And so what we do is we put a double in place. A great example of this is, let's say I want the system to, when I write to the hard drive, that writing command to fail because the hard drive is full or out of space or something. Well, we don't create a test environment with a hard drive that's out of space. But what you would do is you would put in a double in place when you wanted to test, oh, do I know how to handle the situation that I've run out of disk space? And so you stick in that double, and the double, when you try to write out to the file via the double, it says, oh no, I'm out of disk space. And then you can test your code, like, did it actually handle that? But of course you did never actually run out of disk space. It lets you fake that sort of scenario in case. Same thing people talk about for network failures. You're not going to go around unplugging network cables in the midst of a test. Well, you use a double to set up those failure conditions. So there's a lot of those sort of examples out there. It's a tool to be used, but just because you have the tool, don't go banging around with it unless you actually need to use the tool. Otherwise, you're going to be putting all sorts of extra complexity into your tests that aren't actually necessary. All right.